Okay. Is what? That's the same thing, right? Sine alpha over A equals sine gamma over C. Okay. Alright. So basically it looks like it's easy to prove those two are equal. How about the third one? Before we get this one into this equation or this identity, we need to consider more. Okay, now what is more? This triangle would be very nice if the triangle is really like this. That's very nice. But can the triangle be like this? Not really that nice. You see, here this angle is no longer than 90 degrees. So alpha is bigger than 90 degrees. Okay? So then the triangle would be like this. Then the things will be a little bit different. If you look at H, you can look at H in two ways. Okay? One is look at this triangle, B, C, and this vertex. That's a right triangle. B, C, and this vertex, right triangle. So you have H over A is sine gamma again. Okay. So H over A is sine gamma. Yeah, H over A is sine gamma again. So this is fine for this one. Again, both sides times A. You can cancel this A with this A. So you have H equals sine gamma times A. Yeah, this is fine for H equals A sine gamma. But how about if you look at this triangle, B, A, and this vertex, then H over C, C is the hypotenuse, H over C will be sine this angle. But you know, this angle is 180 degrees minus alpha. So you may say, H over C then is sine pi minus alpha, or 180 degrees minus alpha. So that would be this case then. Okay. Again, if both sides times C, then you can cancel this C. So you have H equals C times sine pi minus alpha. Actually, sine pi minus alpha equals sine alpha. So you see C sine alpha for the first case and C sine alpha for the second case. So in this case, you still have a C sine alpha. C sine alpha. And those two H's, this H is the same H. Okay? Yeah, they are still equal. Why is that? Why is that? Why is sine pi minus alpha equals sine alpha? So far we can explain this in many different ways. Here is the way down below it. Here is I put the remark. Those two are the same. Those two are the same. Why? You see, sine one angle minus another. Sine is what? Sine, cosine, cosine, sine. Here minus, here minus. You know, sine pi is 0. So 0 crashes this product. So this one disappeared. And then cosine pi is -1. Special angles. So here is 0, here is -1. But there is negative in front of it. So negative is positive. Again, this part is 0. So then you have negative is positive. So only sine alpha left over. That's why they are the same. So still in this case, you have h equals a sine gamma, h equals c sine alpha. So still those two, you see, a sine gamma, c sine alpha, a sine gamma, c sine alpha. So still they are equal because those two are the same h's. Okay? The difference is that this h is this h and this h is this h. Okay, so these are the only two possibilities for alpha, because alpha can be less than 90 degrees and alpha can be also greater than less than 90 can be also greater than can be equal to, okay, can be equal to h. In that case, that will be a right triangle. Okay, the case then might be even easier in that way. Okay, now then we still have a sine gamma equals c sine alpha. Again, both sides divided by ac. We then have this thing, sine alpha over a equals sine gamma over c. Okay, then this tells us what? Sine alpha in this one, sine alpha over a, this side, is sine gamma over c is this side. That's a very nice formula. Okay, so we actually proved that they are equal. Here we did is you use B to draw a vertical line perpendicular to AC. You can draw a vertical line from A to BC. You can draw it. Okay, or C to AB, or C to AB. In any way, you will get either sine beta over B equals sine gamma over C, or sine beta over B equals sine alpha over A. Either you get that or you get that. Okay, so similar way you can do it. So that's why this is true. Actually, I put it down right here is similarly one can prove either sine alpha over A equals sine beta over B, or sine beta over B equals sine gamma over C. Okay, because those two are already equal, we have proved. If you get sine beta over B equals that, then of course, because those two are already equal, so still you have these three. If you can prove sine beta over B equals sine gamma over C, because those two again are equal, then you can insert this third one into the middle. And this is called the law of sine. Okay. You know, this is the proof, and it has this one, law of sine is widely used in many applications in land survey everywhere. Okay, and this is the proof, and I hope you can read through it, and next time I'll give you some examples. Okay, I'll see you next time.